Number 11 asks us to determine the values for all the variables in the following system. Okay, so what we want to do is we want to create from these three equations, we want to create two equations in two variables. So what I'm going to do is I'm actually going to line up this first equation, so the 2x minus 4y plus 5z equals negative 33, with this last equation, with the third one, negative 2x plus 2y minus 3z equals 19. I chose these two just because you can see when you go to combine them, the first two terms are going to cancel off. So it leaves us with, when we combine our like terms, negative 2y plus 2z equals negative 14. So what I created here was an equation that has just a y and a z term in it. So now what I want to do is I want to take any other two equations and try to create, another equation with just y's and z's. So this time what I'm going to do is I'm going to again take my first equation, but I'm going to multiply everything in this first equation by 2. So I'll do that off to the side here. So I'm going to take, I'm going to multiply it by negative 2. So when I take my first equation and make sure to multiply the right side by negative 2 as well, I distribute that negative 2 to all terms. So it's going to leave me with negative 4x plus 8y minus 10z. Ooh, let's hope we can squeeze this, equals 66. Now, the reason I chose to do this, to multiply it by negative 2, is because if I take this second equation, it starts with a positive 4x, and this new equation that I just made over here has a negative 4x, so when I line those up, we're going to, again, get our x's to cancel off. So I'm going to take this second equation, and I'm just going to line it up right underneath the equation I made. So 4x minus y. I'm going to leave a space because we don't have any z's in that, so equals negative 5. So now these are the two equations I'm going to combine. So the first two terms cancel off, and then 8y minus y would be 7y. I'm going to bring down my negative 10z, and 66 minus 5 is 61. So now what I have here is two equations with y's and z's. And when you have two equations with two variables, you could now solve. Now what we do need to do first is we have to get either our y's or our z's to cancel off. So if I look at the equation in blue, my term right here says negative 10z. And if I look at my equation in red, I have a positive 2z. So if I multiply my red equation by 5, I will get my z's to cancel off. So let me just do that. I'm going to just put a 5 in front of this equation. And when I distribute that, I'll have negative 10y plus 10z equals negative 70. So I'm going to now bring this over underneath the blue equation. Okay, so now that we did that, when we go to combine like terms, our positive and negative 10z are going to cancel off. So let's just combine like terms. 7y minus 10y is negative 3y, and then 61 minus 70 is negative 9. So if we want to solve for y, just divide both sides of the equation by negative 3. So it leaves us with y equals 3. There's a solution to one of our variables. So now, if we take a look back at our original equations, this second equation here, 4x minus y equals negative 5, it only contains an x and a y, and since we know what y is equal to, we could easily solve for x. So I'm going to rewrite that equation over here, 4x minus y equals negative 5, and since we know that y is equal to 3, let's just replace that y with a 3, and we can solve. So to solve, add 3 to both sides, leaving you with 4x equals negative 2, and divide by 4. So you're left with x equals, you could write either negative 0.5 or negative 1/2. So now we have our x and we have our y. So now we can use any of the equations to solve for z. I'll just rewrite this first equation here. So I'll just rewrite 2x minus 4y plus 5z equals negative 33. And since we know that x is negative a half, I'm going to substitute that in for the x. Since we know that y, I'm going to just make this negative over here a little bigger. Since we know that y is 3, we could substitute that in. And we're going to leave the z as is because that's what we're solving for. Okay, so 2 times negative a half is negative 1. Bring down the minus sign. 4 times 3 is 12. And then I'm going to bring down my plus 5z equals negative 33. So when I combine my like terms right here, negative 1 minus 12 gives me negative 13. So we have negative 13 plus 5z equals negative 33. All right, so all we have to do to finish is just add 13 to both sides of the equation, and then divide by 5. So we wind up with z equals negative 4. Okay, so we have x equals negative 1/2, y equals 3, and z equals negative 1/4. And you can plug all three of these values back into all three original equations to make sure it checks. Or you could just check in your calculator using, a matrix. The final question of the review sheet just asks you to solve the following system graphically. Okay, so I'm going to start off I'm actually going to graph the circle first. So if we take a look at this equation right here, what we want to do is we want to get it in center radius form. So I'm first going to group my x terms together, and I'm going to put an empty box here because I'm going to need to complete the square. Then I'm going to group my y terms together. I'm going to put another empty box here. And I'm going to take this negative 20 and bring it to the right-hand side of the equation. So when I do, it becomes a positive 20. And let's put 2 more boxes on the right side of the equation because whatever you add to the left, you have to also add to the right to keep it equal, to keep it equivalent. Okay, so now to find the number that goes in this first box, you look at the term right before it. We have a negative 4x. What you're going to do is you're going to take half of the negative 4 and then square it. So half of negative 4 would be negative 2, and negative 2 squared is positive 4. So I'm going to add 4 right here. And whatever I do to the left, I have to do the right-hand side of the equation also. Okay, same thing with the second box. I look at the term before it. I have a negative 2. If I take half of negative 2, it's negative 1, and then you square it. So negative 1 squared would be positive 1. So I'm going to add that to the left-hand and the right-hand side of the equation. Okay, now if you were to factor this first trinomial, it would factor to be x minus 2 times x minus 2, which, since we have 2 of the same thing, we can write as x minus 2 squared. Now I'll bring down the plus sign, and if I were to factor this next trinomial, it would give me y minus 1 times y minus 1, which we can write as y minus 1 squared. And on the right-hand side of the equation, just add 20 plus 4 plus 1 is 25. So based on this, we know that the center of our circle is going to have the coordinates 2, 1. Keep in mind, if this is x minus 2 and this is y minus 1, it's x minus the x coordinate. So the x coordinate would be 2. And it's y minus the y coordinate. So the y coordinate would be 1. Basically, it's just the opposite signs. If this is minus 2, the center is positive 2. If this is minus 1, the center is positive 1. And then in order to find the radius, you just take the square root of the right-hand side of the equation. So the square root of 25 is 5. Okay, so if we want to graph this, we know we have a center at 2, 1. So I put a point there. And then I might have a little trouble graphing this without a compass, but I will do my best. So if the radius is 5, I'm just going to go out 5 in each direction. 1, 2, 3, 4, 5 up. 5 to the right, 1, 2, 3, 4, 5. 5 down, 1, 2, 3, 4, 5. And then 5 to the left, 1, 2, 3, 4, 5. Now you guys would be using a compass. Unfortunately, I don't have access on this, so I'm just going to freehand this as best as I can. Right, there we go. And always label. So you can label the original equation. You can label whatever the equation is in center radius form. I will label it the original equation. X squared plus y squared minus 4x minus 2y minus 20 equals 0. Okay, so now the next thing we want to do is we want to take the line. So the 2x plus y equals 15. And we just want to get y by itself. So we could subtract 2x from both sides, leaving you with y equals negative 2x plus 15. So if I wanted to graph this, my y-intercept is 15. So I can go up to 15 on the y-axis and put a point. And then my slope is negative 2. So I can go down 2 over 1, down 2 over 1. Now the problem with this set of axes is I can't really start off at 15 on the y-axis because I think the y-axis only goes up to 10. So what we could do instead is we could go to y equals in our calculator, and you can plug in into y1, negative 2x plus 15. And what we'll do is we'll just look at our table of values and we'll copy down some of these points. Okay, so it looks like I can fit, let's see, 3, 9 is the first point I'm going to actually be able to fit on this graph. 4, 7, 5, 5, 6, 3, 7, 1. And you could keep going. I mean, basically, as the x's are going up by 1, the y's are going down by 2. So I'm just going to graph these for now. So we have 3, 9, 4, 7. Really just going from this point down 2 over 1. 5, 5, 6, 3, 7, 1, and so on. And you are going to want to connect those, which you would be using a ruler. I am going to do my best to freehand this here, which came out pretty bad. Okay, so now what we're going to do is we're going to label the equation. You can either label the original or y equals negative 2x plus 15. I guess I'll just stick with the original since I did that with the circle, but it does not matter either way. And to answer the question, if we want to find the solutions, we have to label the points of intersection. Now, it looks like here the points of intersection to me are 5, 5, and 7, 1. So I'm going to double check, though, because I did not have a compass or a ruler accessible to me with this. So in order to check, I'm just going to sub them back into the original equations and see how that works out. So if I take my original equation, 2x plus y equals 15, which I just rewrote here, and take the coordinate 5, 5, and substitute in 5 for x and 5 for y, so 5 for x and 5 for y, I do get both sides of the equation to equal 15. If I also take that same original equation and plug in an x coordinate of 7 and a y coordinate of 1, like I did here and here, I also get both sides of the equation to equal 15. So the point 5, 5 definitely checks. Okay, so now let's check the point 7, 1. So if I substitute the coordinates 5, 5 into the original equation, x squared plus y squared minus 4x minus 2y minus 20 equals 0, you can see here that when I substitute in the 5 for x and the 5 for y, I do wind up getting 0 equals 0. So this coordinate checks 5, 5 in the second equation as well. And let me just check 7, 1 in the same equation. Okay, so here you could see I substituted in the 7 for the x's and the 1 for the y, and I, again, got 0 on the left-hand side of the equation, so it checks with the 0 on the right-hand side of the equation. So 5, 5 and 7, 1, these are 2 points of intersection.